Thank you. Well, thanks for the opportunity to share some of our research. But I will say that we're located 8 minutes away, but all of this work is 2.5 to 3 hours north. So it's not really close to where we are. So just to give you a little bit of an overview of where we are operating. I said here we are in Columbus. Most of our work is north and west of here. As I said, I did spend some time in the modeling arena before I got here. I spent about 10 years on the SWAT modeling development team, and at that point, it was interesting, and I joke that I'm a reformed modeler, but really what that really came down to be is I got a call one day when I was doing my dissertation work, and I was in charge at that point of the GLEAMS model, and the individual said, well, I want to use it for an impact statement, an environmental impact statement, and he said, but I don't have any data. And so how do we use the model? And at that point, it became very clear to me that data was very important. And so when I had the opportunity to come here into Columbus, we wanted to set out and look at how do we collect data? How do we get the information that the models need, and what can we learn from that? So that's really how all this really started. So as I said, we've been working out on private lands. Now we started back a couple of initiatives. The Source Water Protection Initiative when I first got here was to protect the city of Columbus drinking water supply. That's morphed into working with the NRCS and their SEEP program, the Conservation Effects Assessment Project, the Mississippi River Basin Initiative, and now what I'll call the Lake Erie watershed and the phosphorus issues associated with that. So when we've gone out, we try to set up, we work on these private lands. We go and talk to a farmer, we sit down and across the table from them, and we want to try to get a surface and subsurface component to this. And so we've been fortunate. We've got, we're working on 40 fields right now, and they're paired. So 20 pairs where we've got surface and subsurface. So we've got, they said we've got this sort of paired site where we've got the subsurface, we've got the surface. You can see we've got, on our surface, we do put H flumes on all those. So we do have control volumes. And the same thing with our tile drainage. We do have compound weirs on our tile drainage outlets. So we've got automated samplers on all those. We're looking at a variety, which I'm going to talk a little bit about some of the practices that we're quantifying and measuring the impacts of right now. To date, we've got roughly 166 site years of data, and that includes that surface and subsurface component to that. So we've got a pretty good idea of what's happening on some of these sites. And we think that they're representative of agriculture, at least in this northwest quadrant of Ohio. And I guess the other part is the tile drainage. And that's, in this part of the country, is I guess, unique. I'm going to talk a little bit about that. But roughly 90%, 85-90% of the soils are poorly drained or very poorly drained in that region. And you see the darker blue, the percent of the county with tile drainage. And I would argue that the percent of ag land with tile drainage is upwards of 95 to 100%. So I'm going to just go into a little bit of the data, the overarching data, some of the things that we've seen. So if we look at this, this is sort of our water balance, if you will. Well, we've got, you really see the importance of tile drainage, and we get that, and that sort of that winter, springtime is when we get the bulk of of the tile drainage here. And so it's we could not farm, we could not access the fields if we did not have this tile drainage during this period. So it's very important for us at that point. Surface runoff, we do get surface runoff, but in this very flat topography up in this in the northwest part of the state, we don't have what I would say is a lot of surface flow. I would say we're talking 7, 10, maybe 15% of the precip gets translated into surface discharge. So let me give a little overview. So this is just some of when we started. So water year 12, I think this just goes up to 16. We've got 17 now. But you can see some of the site data. The dark areas in here are the subsurface, that tile component. The surface is the bar on top of that, the white bar on top of that. The red line, let me talk a little bit about the red line in here, and this is something that I created. It's been used out of context. So Laura talked about the 40% reduction that has been proposed or is out there now with the binational agreement in the Annex 4. I took that number, that 40%, and I said, well, if 40% is the reduction, 60% should be allowable. So I took that 60% and I divided that equally among every acre in the Maumee Basin. And that's what that red line represents. It says that if we wanted to get to a 40% reduction and 60% is allowed, then every farmer would have to get down to basically 0.3 kilograms per hectare. If we could do that on every acre, then we meet that 40% reduction. That's treating everything equal. So that's where I came up with that number. And as you can see, we've added more sites in time. And what you see on average is we're doing a pretty good job in terms of agriculture meeting this goal. Now, do we have some issues? Absolutely we do. And I'll share some little bit data on those here in just a little bit. But if you look at this, again, we have this springtime goal and we have the annual goals. And if you look at that right now across these sites on annual, and we look at individual years rather than the average, then we've got about 56% or 57% that are exceeding that target goal. So we've got a lot of work to do. And if we look at it just in this critical period of March through July, it's even more than that. It's upwards of 75% of these farmers that we're working with that don't meet that goal. The other thing to note, as I said, is tile drainage accounts for about 70%, 75% of the dissolved phosphorus loads in this of the farmers that we're working with. But again, the tile drainage, and that's something I didn't put a slide up here. Wasn't sure about my time allotment. I can go on for quite some time, but you don't want to hear that. Tile drainage, what I will say is if we look at this, the concentrations of dissolved phosphorus that we see coming out of the tile drainage is about 1/3 to 1/4 of what we see coming off of the surface on an event basis, the event mean concentrations. So when we think about solutions, or we had rather have that water, in my opinion, to move through the soil, to move in through the tile, because the water is going to go somewhere. So I'd a whole lot rather personally having it going through this natural filter of the soil and coming out at 1/3 to 1/4 of the concentration than what we see coming across the surface. Now, granted, we do have more water. We do, from a water balance, because of the amount of water coming through the tile, we see about a 10 to 25% increase in the total volume exiting the site. But that volume generally has a lot less concentration. So our loadings are generally less when we look at it in a combined state. So this is a busy graph. Again, this is that same sort of this solid line here. I'm going to get you oriented here. This really pulls everything together. When we start talking about soil test, you can see we've got soil test ranging down in the critical level here, all the way upwards of 400 or 500 parts per million in the soil. And again, this is that 0.29 or 0.3 kilograms per hectare line. The vertical lines are our tri-state recommendations, the critical level and the maintenance range, this being the maintenance range here. So what I want to point you to is that, yes, in general, as the soil test levels increase, our risk potential increases. But that risk increase does not equal an environmental risk necessarily. I mean, we have sites here, out in the 75, 80, 100 parts per million range where we're below this threshold. We have sites out here in the 150, 175 that are at or below that threshold. In general, yes, it is increasing. And I think this gets back to Chad's point, what's available. And every soil, just like every soil is different from a plant uptake, it's also from a risk potential and what's in that solution. So again, I think this is very important. I did also put on here, and I realize I've got one of them that is wrong. 12 was a dry year rather than a wet year, but the 15 and 17 were wet years. So the blues are generally the wetter years, and you can see they generally are above the other sites. So you can see what the impact of that precipitation is. Similarly, one of the things that we're doing now is to look at these individual fields and try to come up with what I'll call P-balances. And again, looking at what we apply versus what we take off in the crop. And again, look at the little reds and the grays. This is that environmental part. This is what's causing our Lake Erie and Grand Lake St. Mary's to be green. These are very, very small percentages of what we're looking at in the water balance, or in the balance, the phosphorus balance as a whole. You can see that also I've got this separated by organic sources versus inorganic. With organic, we tend to put more on, and in some cases we tend to put a whole lot more on than what we're getting out, what we're taking off with the crop in those particular instances. Weather plays a major role in this. This is all of our data from all of our sites. I think this is 5,000, 6,000 rainfall events collectively. So what we see is, if we look at the top 20% of our rainfall, that works out to be about an inch and a half of rainfall, but that accounts for nearly 40% of what we're seeing come out in terms of the subsurface discharge and loading, versus about 60% in the surface. So we can see that rainfall is critical. It's those larger events. So when we start thinking about practices or mitigation strategies, I think water management has to be a component of that. It has to be a serious component of that. How can we store another inch or inch and a half of water in our landscape? Is it through the ditches? Is it in our soil profile? What other mechanisms do we have? And by storing more water in the landscape, I think we can keep from losing those nutrients. So when I start thinking about practices, and I'm going to switch a little bit, those were the overarching data. So to think about practices that we can do, we talk about infield practices, edge of field, and in stream. And this is just hypothetical, this line, this efficiency line or percent reduction. But I do think that we have more bang for the buck potential in the field and at the edge of field. Once we get to the stream, it's very costly and it's more difficult. So these are some of the questions that we're starting to ask now is what is that most effective scale to address water quality? What should those practices be? And are there trade-offs? I mean, this group is focused on phosphorus, but we can't lose sight of nitrogen. Just because if we start to address the phosphorus issue, we could have an unintended consequence of nitrogen or sediment, or especially when we start talking about placement. I mean, Laura brought up the potential for incorporation, and I absolutely agree we need to do some of that, but what is the optimal level of those different practices? So these are, so across our edge of field sites, these are some of the practices that we're investigating at this point. A lot of them have to do with the 4 R's. Back about 4 or 5 years ago, there were 30 different organizations in the state. Somebody here correct me if I'm wrong, but agribusinesses that got on board and signed this pact to promote the 4 R's. And now there's a voluntary approach in the state that's being led that industry is getting involved with. I think we've got 41 retailers now. Over half of the western Lake Erie Basin is covered now under this voluntary 4R approach. So we've been investigating some of those practices. And again, I don't have any data on this, but we do have producers getting to Chad's point, that have not applied phosphorus, more so due to weather than anything. They couldn't get in the field when they wanted to, but they've not applied phosphorus in 6 years. And they've not seen a yield drop yet. So where's that critical level? They're in the agronomic range right now. I think their soil test level is 28 parts per million Mehlich. So how low can they go before they start seeing that yield drop? But we've got some different, we're looking at half rates, full rates. We're looking at timing. Again, to get more to what Laura's talking about with stratification, looking at the surface versus subsurface applications. We've also done a little bit with using gypsum as an amendment, a soil amendment on, we've got a couple of sites that we've done that on. We've got, there's one paper out on that now and some other preliminary data we could talk about. Cover crops versus no cover crops we've been involved in, and crop rotation. And that's as much as in trying to get small grains back into the rotation, or even some perennials in a couple of instances. We're putting in, especially producers that have access to animals, or can provide silage corn and other things, or alfalfa even we're putting in. So and then we've also done some drainage water management things at the edge of fields, some wood chip bioreactors and the P filters that Chad's been involved in, and then also this idea of a two-stage ditch design. So I'm going to talk just a little bit about a few of these. First of all, let's talk about fertilizer source. And we talk about manure, organic versus inorganic sources. This was a side-by-side comparison. If we look at this treatment period, again, these are just the dissolved and the total. We've got the concentrations versus the loadings. Field 2 had the dairy manure. Field 1 was MAP. They were put on at equal rates. We see no difference in the concentrations or the loadings, and whether we're talking total phosphorus or dissolved phosphorus. So when we start talking about the source of phosphorus, it's a rate issue. It's not necessarily a source, especially when we start talking organic versus inorganic. At least that's from this particular study anyway. We talk a little bit about application rate, and this is some work that I collaborated with Doug Smith on. Robin Wilson here at Ohio State had done a big survey, and we start seeing what we think we're from the tri-state, what is recommended versus what's being applied. For the most part, I can't remember yet. So 90% of the fields have P application at or below the recommendations. 58% of the fields had 0 applied for the rotation. This is the problem. Look at this axis. We've got 0 recommendation, but we've got producers that are putting a lot of fertilizer on. And so those are some of the issues that we're trying to get a little bit of a handle on now, of what's going on. With respect to timing, P losses and time of application, this is some work just from the fields that we've been involved in, those 40 fields that I talk about. So when we look at tile drainage and surface runoff, this is just precipitation amount on the y-axis versus days since application. Generally, the closer we are to days since application to those larger precipitation events, those are the warmer colors. This is nothing new. This is what we expected to see, is that, the closer you are to precipitation with application, the more potential you have for loss. This is a little bit about, Laura touched a little bit about macropore flow, and this is generally what we see. We do have a lot of cracks in our soils. This is a stadia rod. I mean, this rod it's 1.5 inches wide. That's down about 7 inches deep in a crack in one of our edge of field sites. This is some smoke tests done by Martin Shipitalo and Frank Gibbs. You see that surface connection, and we see that correlation as well. We see those concentrations coming out, those peak concentrations coming out at the same time as the peak the hydrograph in the tile drainage. So we do know we have that preferential flow, those fast flow processes occurring. And like Laura said, when we look at our soil peak concentrations on the surface as they go down, so when we're connected and we get a rainfall event, we've just got a short circuit going into our tile drainage. Well, here, this is from Martin here. So this is that, you can see, this was an earthworm burrow or a macropore of some sort, but you can see here's the tile drainage, and you can see that direct path. So we've done some investigation. This was work that Mark Williams led. Mark postdoced with me for 3 years. Now he's over in West Lafayette doing a fantastic job. But we did some broadcast inject and tillage studies on some pan lysimeters, and what you can see is when we broadcast that, the amount that we got through coming into those lysimeters was significantly greater than what it was when we either injected it or did some tillage. And again, this is more plot scale, so it's just a rototill of that. But you can see the impact of that, and broadcasting, leaving on the surface, especially in these soils where we are prone to preferential flow, it can be a significant loss. So this is one, I'll talk a little bit about the cover catch crop and the rate study. This is one that this is very preliminary data. This was started last year. The producer put some mustard cover on these two sites versus no cover. It's also a rate study where this was liquid dairy manure. This is 3 months of data. What we found is there's absolutely no difference with respect to phosphorus. So when we start talking catch crops, we don't expect to see a big difference with phosphorus, but we do see a big difference with respect to nitrogen in these. And we also see some water savings. The amount of water that's leaving the site as tile drainage is much less in those sites where we had cover crops versus the sites where we did not. I know he's already standing up, and I'm only half done. That's all right. I'll hurry. So when we start thinking about ground cover, and this was some work another one of my postdocs worked on. The grass type actually was associated with lower tile discharge. So if we had those grass covers, those corn, wheat, forage grasses, those were a lot different than some of the other cropping. But it had less of an effect on the event size or the amount of discharge associated with those events. I'll go real quickly through this. Edge of field practices. This is this drainage water management where we artificially raise the outlet elevation of tile. We've got some pretty good data on that show where we do have that drainage water management. This B4, we get some pretty significant reductions in the amount of dissolved phosphorus. More so, we get a bigger benefit from nitrogen. The concern with this type of practice with respect to phosphorus is the potential that we create a reducing condition. So that some of that phosphorus that's bound to that iron could be we reduce, and that phosphorus could come back in suspension. Chen Tan and the group out of Canada have shown this. And generally, we still see a reduction in phosphorus, but the concentration generally does increase a little bit with that practice. This is just getting to some of the phosphorus removal structures Chad's been involved with here, helping us with. We do see some benefit. This happened to be one that we exhausted. If we had read Andrew's papers from back earlier, we would have known that dust from poultry barns actually exhausted right on the top of our filter, and they used it up a lot quicker than we had intended to. But we've remedied that now, and I think we're getting some good data out of that. The other one is this idea of this two-stage ditches. Where we normally have these trapezoidal ditches here, and now we've got this idea. This was really developed by Andy Ward and is being tested out now. But where during these high flows we can take advantage, water can get over the top of these benches. It's more for denitrification promoting. But what happens, and another postdoc, Brittany Hanrahan, right now is looking at the tile drainage. When this tile drainage exits out onto these benches, especially during base flow periods, we've got a lot of potential for binding or attenuating phosphorus, and that's one of the things we're looking at now is how do we maybe change the flow paths here a little bit. So I've already talked about that. This is the tile drainage. You can see this is where we get this is the biggest tile drainage area in the country. One of the things, and the only way I want to address this is Becca asked me to talk a little bit about gaps that I think are out there and some of the modeling stuff that we're involved in. This is systematic tile drainage. farms that are out there, this is, I don't know if this is 35 or 40 foot spacing. You can see these from the air when you fly over them. What are farmers doing now? They're going in and they're splitting those. I mean, we've got farmers going from 50 feet down to 25, 40 to 20. We've got some farmers that are down to 15 feet spacing now. They don't see the lateral flow, and I think it's a soil structure problem, which gets back to some of the soil health issues. If we can enhance our soil quality, get that lateral flow back, the aggregate stability, and move water laterally, I don't think we have to go this low. But right now, farmers are really intensively going in and splitting those tile to get more drainage. We've got an ag engineer on staff, Barry Allred, who's using some technology now to actually go in and using thermal imagery to look at that tile drainage, because a lot of these systems are old. Now, granted, the new systems we have maps on, but the older systems we don't. So if we can somehow get what I'll call drainage intensity, we think that in terms of prediction is going to help us a lot in terms of predicting both discharge and water quality from some of these sites. There's some of the modeling stuff that we talked about, the macropore flow. We worked with Bill Ford. Bill postdoced with me for a while. He's now at the University of Kentucky. He developed a macropore flow routine for the Apex model. We've been working with RIM for several years now, most recently here on the nutrient tracking tool, using a lot of our edge of field data. Daniel Moriasi with ARS is trying to add a new, come up with a better tile drainage routine in the Apex model. SWAT related work, we're working with Limnotech to do some of the edge of field. This is more of the 4R related stuff. They're part of the 4R project. Working with Margaret Kalchik on a lot of different projects. I don't know how many, 3, 4, 5, something like that. We don't know. But and then finally, we're doing stuff with DrainMod. This is with Mohammed Youssef at North Carolina State. Where they're using the model. He's just developed a DrainMod P version, so they're trying to look to see where that, using some of our edge of field to calibrate and validate that. Working with Margaret Gittow over at Purdue and one of her students looking at the Mike Shee model in the Tiffin watershed to again, just trying to represent the practices. We've got one edge of field site in there, so we're sharing data with them. And then also with Dustin Goring, this is with the National Weather Service. That northwest part of Ohio is not very well represented with precipitation gauges, so we're sharing precipitation data with them to try to come up with a better flood forecasting tool in that. So I know I went over time, but I think I had a little extra, so maybe.